Hi, this is Muri reporting from Berlin, and this is part 11 of my Using React Hooks with D3 series. And in this one, I want to show you how to create this force layout we have right here. So it is called force layout because in contrast to the tree chart we did last time, we want physics or forces to define the positioning of our nodes we have right here. So there are three different forces in play. The first one is attached to every node itself, and you can see it when I reload the page, that every node will try to push other nodes away from itself. And this is the first force, and the number you can see here on the top left is the amount of force we are applying to these nodes, and it decays over time, and this is why they are coming to a halt. And yeah, the second force we are applying is attached to my mouse cursor, and it will attract these nodes towards it as long as we apply some force. And the third force is applied when I click, and it will generate this circle which will attract these nodes, and it will also resupply the nodes we have with some force. And you can see that if I click anywhere on the SVG, that the nodes will get attracted to both my circle and my mouse cursor, and this is why they're like positioned in the middle. And yeah, I thought this might open some interesting possibilities, and yeah, we're going to explore force layout in this video, which is also actually pretty new to me. Yeah, so stay tuned. So just a quick note on the app setup before we get started. I have this data right here. It represents the root object and its two children, and also the three children of that first child. And it is important that the nodes have this children property if they actually have children, because D3 will per default look for this children property if you're working with hierarchical data. And this data I'm passing down to both my force tree chart and my tree chart down here. So I'm going to leave the animated tree chart here just to compare the two if needed, because they are quite similar in certain aspects. And what we're not going to do in this video is we're not going to dive into the responsive behavior of the force layout. The force simulation will just restart whenever the dimensions change. We're not gonna bother in this video. So I cleaned up my force tree chart component. This is basically the same boilerplate component which I have been using for a few sessions now. And yeah, what I'm basically doing is I am rendering this SVG, giving it this SVG ref, which I'm creating here, and then I am accessing this SVG DOM element inside of my use effect hook and wrapping it with this D3 select function to be able to do some D3 magic later on. And the only thing that I've copied over from the animated tree chart is this hierarchy utility function from D3, which basically helps us to extract the nodes and the links we have in our data in a flat way. And I just logged out the node and the link data we have right here, and you can see it is just a flat array which describes the data we have. And you can see that the first node has a depth of 0. It stands for this node we have right here, and then come the two nodes with the depth of 1, and then come the 3 nodes with the depth of 2. And same for the link data, and the link data just describes the connections between the nodes we have. And it says, okay, there's a connection between this source node and then this target node. And yeah, these two arrays we will use again for rendering the dots and the lines in our force layout. So the main thing, or the main difference to understand between animated tree chart and the force layout is that the animated tree chart is just rendered once or calculated once, while the force layout is actually a simulation which happens over time. And to demonstrate that, I'm going to import something from D3 called force simulation, which is like the backbone of this entire layout. And then I'm going to go down here and remove these logs here and say const simulation equals force simulation. And here I have to pass in what I want to apply force to. And I want to apply force to my nodes and that is why I have to pass the node data, which I have extracted here earlier. And to show you like that it's happening over time, then I'm going to say on tick and pass in a callback function. And this callback function will get triggered every time the force decays, which we have seen earlier. And to show you the current force level, I can say const or console log current force and say simulation alpha. So the alpha property always stands for the current force value. And if I save this, you will see that the simulation will already start. So calling this will already always start the simulation. And then the like force or the alpha value will start at 1 and decay towards 0 and then stop. So one small correction, this tick callback is not just fired whenever the alpha decays, but it is fired over and over as long as the simulation is running. And the simulation per default starts at the alpha value of 1 and stops when the alpha value reaches 0.001 or something. And I can actually make this simulation run infinitely by saying alpha target 0.2, for example. And this will cause the simulation to start from 0 and work towards an alpha value of 0.2, as you can see here. But the simulation will never stop because the break condition is actually still at 0.001. So you can actually set the like break or the exit condition with another property called alpha min. And you can see here that it says the default minimum alpha value is 0.001. And if I say alpha min 0.5, then you can see that the simulation will stop when it reaches this value, although the target was 0.2. So now that we have set up our force simulation and have seen how it works, we now have to do two things. The first is we still have to render our nodes and links and whatever here inside of this onTick callback. And the second thing we have to do is we have to define the forces which are in play, because on every tick of this simulation, these forces will like influence or mutate the data here and will change the outcome of the positioning of our nodes we render inside of the onTick callback here. And yeah, these are the two things we have to set up. So here I did a little jump and already rendered out all of the links and nodes and labels and so on, because I didn't want to spend too much time on the general update pattern or the rendering of things in D3. I hope you are familiar with that by now, but if not, please check out my first videos or the video before this one, because in that one we're going through step by step on how to like render the nodes and the links and so on. So yeah, what I'm doing here first is I'm first rendering the links. I am passing in the link data array as a data source, and for each link object I'm rendering a line and attaching the correct 4 attributes which are needed to render a line. And yeah, based on the source and target node object in that link. And the important thing, the very important thing in like to notice here is these X and Y properties. They are actually not generated or not defined at this time when we like extract the links and the nodes from the root object here. They are added during the simulation. And what is actually happening is when I pass in the node data here with all the nodes to the force simulation, the nodes inside that array get influenced or like mutated, they like based on the forces in that simulation. And there are some like default forces which apply there, and during this process they get added some X and Y properties, these nodes, and these nodes are just referenced inside of this link data array, and this is why this X and Y values can also be accessed in this link data array. Yeah, so going on, continuing here, then I'm rendering out the nodes, passing in the node data array this time. And for each node, I'm rendering a circle and attaching the right attributes based on the current node, so the x and y properties which I just mentioned, which are added or generated by this force simulation. And yeah, the same thing for the labels. And as you can see here, there is already some positioning going on, and this is, like I said, because of the default forces that apply during a simulation, even without defining the forces itself. And what we are going to do now is we are going to define the forces that influence these nodes, and see what happens. So now let's get started and define the forces we want to use, which influence our data, and define the x and y positions then for us. And the first force I'm going to define is actually something that I didn't use in the demo before, but I'm just going to use it anyway to demonstrate how it works, and probably remove it later on. So I am going to go here now after the force simulation and just say .force to define a force which influences our data. And first I have to give it a name, and I'm going to call it the center force. This is just arbitrary. And then I'm going to import and use something called force center. This is going to be automatically imported via VS Code for me. And here for this force center function, I just have to pass in an x and a y coordinate to define where the nodes should gravitate to. And because I have my dimensions object here, which contain the width and the height of my SVG, I can just say dimensions.width divided by 2 for the x, and dimensions.height divided by 2 for the y coordinate. And if I save this, you will see that the nodes will be positioned at the center. So now I want to define another force, and to do that, I just have to call another force chain here. And in this one, I want to define a force that makes sure that the nodes push away each other. And I'm going to call it charge to represent that they are electrons which push away each other. And the force function I'm going to use for that is going to be called force many body. And this is a force that is applied to every node. And you can define if they attract or reject or push away each other by adding a strength like that. And if you define the strength -30, then they will push away each other. And if you give it a positive value, then they will attract each other. So I'm going to give it a negative value, -30, which is also the default. And if I save this, you will see that the simulation will start, the alpha will decay, and this force will influence the positioning of our nodes, as you can see here. Yeah, so one force down, and now I want to focus on the force which attracts the nodes towards my mouse cursor when I hover over the SVG. So to do that, I'm going to go all the way down here outside of my simulation and define a event handler for my SVG, which will trigger every time I hover over my SVG. And to do that, I'm going to say SVG on mouse move, and pass in a callback function. And now I want to access the current mouse position on my SVG. And to do that with D3, it's actually a bit quirky. And you have to use a function called mouse and pass in the DOM element, and then it will calculate the x and y coordinates of that mouse for you. So it looks like this. You have to say const coordinates equals mouse, and this will get imported for me automatically. And here I have to pass in the DOM element I want to get the relative coordinates from. So I'm going to say svg ref current, and this is going to contain my x and y coordinates in an array, and this is where I can destructure it like so. And then when the mouse moves, I want to like apply or set up a new force. So now I have set up my mouse move event handler, and I have access to the relative x and y position of my mouse on my SVG. And yeah, during this callback, I then want to set up a new force which influences the position of my nodes based on the position of my mouse. And to do that, I am going to add another force to my simulation, which is even like added during the runtime of the simulation, and say simulation force, and I'm going to call it x and import something from these we call force x, so that like I can influence the x position of a node based on my cursor position. And here I'm just going to pass the x I have received from the mouse function, and the same thing I have to do with for the y force, and I'm going to call it y and import force y and pass it my y coordinate from my mouse function here. And just to make it a bit more like visible what is happening, I am going to assign a strength to these forces, and I'm going to give it a strength of 0.7. And also I want to do the same for the force y. And if I save that and like hover over the SVG, you can see that like they get attracted to my mouse cursor, but then they go back to the middle. And this is happening because of the force center, which is why I have not been using that force. So you might have noticed it looks a bit funny that if I hover here, that the nodes or the smileys that they clump back together, and there's actually a logical explanation for that. So because in the very beginning they are in this clumped state, and the forces they push them away from each other. And when I hover over the SVG, then they get recalculated in their positions, and the force which pushed them away in the first place is no longer there. It fades away. And this is why they clump back together. To fix that emoji cuddling here, we can actually make sure that they have a fixed distance from each other by going to the forces here and adding another force, which I'm going to call force collide. And the force function which I'm going to use for this one is called force collide. And here you just have to say, okay, what is like the minimum distance basically they are away from each other so that they don't overlap. And I'm just going to say 50, or let's say 30. And then you can see that they will not get as close as they did before. Cool. Another thing I want to do is I don't want to use like this hard-coded value for the strength of the force here I'm using for my mouse cursor. I want to make it relative to the depth of the node. As I've shown earlier, this like root node has a depth of 0, then its children have a depth of 1, and then the other children have a depth of 2. So what if we like change the force applied to the node depending on the depth of that node? So I want to make sure that the nodes which have like the higher depth are attracted to my cursor like much harder than the root node, for example. So for that I can pass in the current node which is applied this force, and I can say instead of returning 0.7, return 0.2 plus the depth times 0.2 or 0.15 or something. And the same I am going to do for my y force. And if I reload, you can see that the root node is getting pushed very far away because the nodes with the high depth are like getting very close, and because of the internal force which pushes them away and makes sure that they don't overlap, they also push away each other, and it's very interesting. And yeah, over time the force decays, and yeah, I cannot do anything anymore. Also, I hope you noticed that like this force layout, if I apply the force correctly, it looks just like the animated tree chart down here. So here's the root node, then come the 2 children, and then come the 3 children here. Cool. Yeah, so now I want to add like a force to my mouse click. And to do that, I'm going to go down here and add another event handler, svg on, and click. And here I'm going to pass another callback function, and again retrieve the x and y coordinates of that click with the mouse function. And the first thing I want to do is I want to reapply force to my nodes, because as you've seen, the force fades away, and if I click, I want to restart the simulation with a certain amount of force. And to do that, I can just say simulation simulation alpha. So this is now going to be the current alpha value, and I'm just going to say 0.5, which is not the initial value. And then I'm going to say restart. So this will cause the simulation to restart with an alpha of 0.5. So you can see that the alpha has now faded away, and if I click, I will get some fuel to like reposition these nodes I have right here. Cool. So before I like create this circular force on mouse click, I first want to render a circle which represents this force, which I will add later. And to do that, I'm just going to shamelessly paste in the code I have prepared, and this will just render a circle wherever I click on the SVG. And this has no force whatsoever. It just renders the circle. So now that I have my circle wherever I click on my SVG, I now want to apply force to my nodes depending on the circle I have here. So I want them to get attracted to every point on this orbit or on this circle. So to do that, I'm just going to go to my simulation and add another force, which I'm just going to call orbit for some reason, and then call another force function, or import another force function called force radial. And here I have to pass 3 things: the radius of that radial force, and it is going to be 100, just like my radius here. These damn tooltips, man. So and then I have to pass the x and y coordinates of that circle, and this is going to be x and y from my mouse function here. And if I save this, and maybe wait a second, if I add some more strength to it, like 0.8, you will see that they will kind of get attracted to the circle here and align around this orbit also. So it is not that obvious if I click a bit here on the corners, because the force center is also in play. Yeah, but you get the point, I think. So yeah, we're pretty much done. The only thing I want to do still is I want to remove this force center, because I don't really like it, and it kind of hides the struggle of the nodes between the mouse cursor and the circle here. And it has the consequence that the nodes then start always in the top left corner, but we can actually fix that with a small workaround. So yeah, the centering workaround looks like this. You go to your SVG here and say, bam, you paste in some code. So what I'm basically doing here is I am adding another attribute to my SVG called viewbox. It is a very special and very complex one also. What it basically does here in this case, it shifts the visible part of the SVG to the top left. So it shifts it like 50% to the left and 50% to the top, and it makes the top left corner now like the new center of our SVG. And oh, I have to save that. So now we can see everything starts at the center, and still everything works just like before, because these mouse functions we have been using earlier, or these simulations, they consider this a view box. But if you like add some manual positioning somewhere, then you actually have to consider this this view box shift. And I will show it when I try to now add the like current force here to the top left. And yeah, now to add the current force text label here, I just go to my tick callback and add this here. I'm sorry, I'm just gonna paste it. I basically render a single text element for the entirety of my data, and as text content, I'll use the current alpha. And as you can see here, I am subtracting the half of the width of my SVG and half of the height of my SVG, so that I can center it or position it here on the top left corner, because now everything basically which I do manually is relative to the center of my SVG. And yeah, if I save this, it will look like that. Yeah, it's a bit of a dirty hack, but I think for this case, I think it is more than sufficient. So yeah, that's it for this video. I hope you liked it. Sorry for the shameless copy pastes. I just didn't want to spend too much time on explaining things which I have done like many times before. Yeah, this was a very, very cool session for me, because force layout was something that was on my list for a long time, and I now had the chance to do like a really nice dive into it. So yeah, hope you liked it. Please like drop some comments if you like. Yeah, hope to see you next time. Bye.